Hello students, have you ever wondered why table salt is so stable, but metallic sodium and chlorine gas are dangerously reactive on their own? Or why water, the simplest liquid, forms when hydrogen and oxygen come together? The answer is all about the quest for stability at the atomic level. Atoms become chemically active because they want to achieve a more stable electronic configuration, usually aiming to mimic the noble gases whose outer shells are complete. Elements like sodium, chlorine, oxygen, and hydrogen have incomplete valence shells, making them eager to gain, lose, or share electrons through chemical reactions. Noble gases, with their full outer shells, rarely react. They are the gold standard of atomic stability. Every other element tries to emulate this stability, and that's what drives the vast range of reactions you see in labs, industries, and even inside your own body. Let's look at a classic example, the formation of table salt. Sodium atom, symbol Na, has one electron in its outermost shell. Chlorine atom, symbol Cl, has 7 electrons in its outer shell. Both want to become more stable. In the reaction, sodium donates its single valence electron to chlorine. As a result, sodium becomes a positively charged ion, Na+, and chlorine becomes a negatively charged ion, Cl-. The chemical equation is Na plus Cl gives NaCl. That's sodium plus chlorine gives sodium chloride. This new ionic compound is stable because both Na plus and Cl- have now achieved noble gas configurations. Sodium ion has an octet in its second shell and chloride ion in its third shell. Now let's explore another ionic compound, magnesium oxide. Magnesium, or Mg, has 2 electrons in its outermost shell. Oxygen, or O, needs 2 electrons to complete its octet. Magnesium loses 2 electrons, becoming Mg2+. Oxygen gains those 2 electrons, becoming O2-. So the reaction goes Mg plus O gives MgO, that is, magnesium plus oxygen yields magnesium oxide. Both ions formed, Mg2 plus and O2-, are now stable as they each have full outer shells. This is why magnesium oxide is so unreactive once formed. Not all atoms transfer electrons, some prefer to share. Let's take hydrogen as an example. Each hydrogen atom, symbol H, has just 1 electron but needs 2 for a full first shell, the duplet rule. When 2 hydrogen atoms come close, they share their single electrons, forming a covalent bond and creating a stable H2 molecule. Mechanism-wise, this is a shared pair of electrons depicted by electron dot or Lewis structure. Now, each hydrogen atom feels like it has 2 electrons in its shell, achieving stability just like helium. Here's a reaction you witness every day, the formation of water. Oxygen atom, symbol O, has 6 electrons in its valence shell and needs 2 more to reach an octet. Each hydrogen atom brings 1 electron, and together they share electrons to form 2 OH covalent bonds. The chemical equation is 2H plus O gives H2O, 2 hydrogen atoms plus 1 oxygen atom yield water. Water's unique bend shape and polarity come from the way electrons are shared and the lone pairs on oxygen. This explains so much about water's amazing properties. Atoms can also join forces in more complex ways to create polyatomic ions. The ammonium ion, NH4+, forms when nitrogen shares electrons with 4 hydrogen atoms, giving nitrogen a stable octet. The sulfate ion, SO4-, is built when sulfur shares and distributes electrons with 4 oxygen atoms. Each atom in the structure gets a stable octet. These polyatomic ions showcase how atoms use both sharing and electron transfer to achieve stability. You'll find these ions everywhere, in fertilizers, cleaning agents, and biological systems. To sum up, the drive to attain a stable electronic configuration, like a noble gas, is what fuels all chemical bonding. Whether it's sodium chloride in your kitchen or water in your glass, every compound is born from atoms reaching for stability. By understanding these mechanisms, chemists can predict new materials, design medicines, and even explain biological processes at the molecular level. Remember, chemistry is not just a subject, it's the story of how atoms, by gaining, losing, or sharing electrons, build everything around us. I hope this session showed you how the invisible activity of atoms creates the visible world. Catch you in the next class for more adventures in chemistry.